So we now move to example 6. Solve the D. T squared x, t squared plus 9x is equal to 7 sine 3t given that when t is equal to 0, x is equal to 3, and dx dt is equals to 2, and dx dt is equals to 2. So in our solution, we can see from this indication, since we have dx dt, it shows x is a function of t. So we'll be solving for x. X will be equal to xe plus xp. Now this implies what? D squared plus 9 into xc is equals to 0. Auxiliary quadratic equation will be m squared plus 9 is equals to 0. So m squared will be equal to negative 9. So m will be equal to plus or minus 3j. Root of negative 9 is a plus or minus 3j, which resembles 0 plus or minus 3j. This is equivalent to alpha plus or minus beta j. And therefore we can pick our beta and pick our alpha. And pick our beta and our alpha. Therefore we can now be able to write down the value of the complementary function, the expression for complementary function. So we say now, our xc will be equal to e power 0t into a cos, because our beta is 3, cos 3t plus b sine 3t. E power 0t is just 1, so this simplifies to a cos 3t plus b sine 3t plus b sine 3t. Now we start by letting for our xp. What we have on the right hand side, there is a sine 3t. So we'll say it will be equal to k1 sine 3t plus k2 cos 3t. These are just arbitrary constant. Somebody can use any type of arbitrary constant. You can use k, you can use even b, you can use d, you can use c1, c2, whichever. Now when we have this, and just a minute, let me write sine 3t plus k2 cos 3t. Now, a constant multiplying sine 3t is already contained in our complementary function, because this is a constant multiplying sine 3t. So we cannot duplicate what is already contained in our complementary function. So what we are going to do is to deviate from that. So we are going to multiply this one with a polynomial and this one also with a polynomial. And the polynomial constant, because x is a function of t, the polynomial constant is t. Now, k1 multiplying t multiplying sin 3t, we don't see it here. K2 multiplying t multiplying cos 3t, we don't have it here. So this is quite different from this, and hence now our letting can now be said to be valid. And if it is valid, we can do some operations on it. So we are doing operation by getting the first derivative. First derivative will be what here? A product of two functions. We are going to keep one constant, differentiate the other as we proceed. So we are differentiating sin 3t. 3 will come forward. It will be 3k1 t cos 3t. We now keep sin 3t constant, differentiate t. We simply get k1 sin 3t. We differentiate cos 3t, we maintain t. We get now, here it won't be a plus, it would be a minus. So minus 3k2 t sin 3t. Now, we keep this one constant, differentiate t, we get 1. So it will be plus k2 cos 3t. We go for second derivative. Second derivative, which will be what? We are here. This one will give us minus 9k1 t sin 3t. Plus now, differentiate t, we get 3k1 cos 3t. We are here, plus 3k1 cos 3t. We are here now, we say minus 9k2 t cos 3t. T cos 3t minus 3k2 sin 3t. And when we differentiate this, we may get minus 3k2 sin 3t. Which simplifies to what? It simplifies to what? We have minus 9k1 t sin 3t plus 6k1 cos 3t minus 9k2 t cos 3t minus 6k1, 6k2 sin 3t, sin 3t. So, but we know something. D squared plus 9, D squared plus 9 into XP. This is what will give us the 7 sin 3t. The 7 sin 3t. So this implies we have now d squared multiplying xp, we have minus 9k1 t sin 3t plus 6k1 cos 3t minus 9k2 t cos 3t minus 6k2 sin 3t plus 9 times the expression for xp, 9k1 t sin 3t plus 9k2 t cos 3t. This is what we equate to 7 sine 3t. 7 sine 3t. Now when we simplify this one further, this one will cancel that. This one is going to cancel this. So we remain with 6k1 cos 3t. 6k1 cos 3t. 6k1 cos 3t minus 6k2 sine 3t. This is what should be equated to 7 sine 3t. 7 sine 3t. Therefore, we can see clearly here 6k1 then must be equal to 0, which implies what? k1 is equals to 0. 6k minus 6k2 seems to be equal to 7. Therefore, k2 is equal to minus 7 all over 6. Minus 7 all over 6. Therefore, xp is equals to k2, which is minus 7 all over 6 t cos 3t. The general solution, x will be equal to xc plus xp, which will be equal to a cos 3t plus b sin 3t minus 7 all over 6 t cos 3t. Now, since we were given some conditions, we can now move to particular solution. We can now move to particular solution. And for particular solution, we need to determine the expression for dx dt. Dx dt will be equal to what? It will be minus 3a sine 3t plus 3b cos 3t. 3b cos 3t minus 7 all over 2. 7 all over 2 t sine 3t. 7 all over 2 t sine 3t. Now it is a plus 7 all over 2 t sine 3t, then minus 7 all over 6 cos 3t. So we say when t is equals to 0, x is equals to 3. When t is equal to 0, x is equals to 3. So we say when t is equal to 0, x is equal to 3. So where there is x, we input 3. X, we input 3. So 3, when t is 0, we simply have this one as a. So 3 is equal to a. Since sine 0 is 0, when you input 0 where there was t here, you also get a 0. Now when t is equals to 0, dx dt is equals to 3. This implies what? This implies 3 dx dt is equals to 2, not 3. Dx dt is equals to 2. This implies 2 is equals to. This implies 2 is equals to, we are using this expression. When t is 0, this will be 0. Here we'll have 3b. This one will have a 0, and we'll have minus 7 all over 6. We'll have minus 7 all over 6. When t is 0 here, this one will give us minus 7 all over 6. So our b, 3b seems to be equal to 19 all over 6. 19 all over 6. Therefore, b will be equal to 19 all over 18. Therefore, the particular solution, our x, particular solution, our x will be equal to a, 3 cos 3t, b, 19 all over 18 sin 3t, now minus 7 all over 6 t cos 3t, t cos 3t. And that is now the solution to that differential equation. Now we are in our example 7 is where you have a mixture of functions on your right hand side of the differential equation. We have a polynomial and we also have an exponential. So we'd like to see how this one can be solved. So in our solution, y will be equal to yc plus yp. This implies what? D squared minus 4d plus 5 into yc is equals to what? 0. This implies, from there we can develop what is known as auxiliary quadratic equation, AQE, which will be m squared minus 4m plus 5 is equals to 0. M will then be equal to 4 plus or minus root of 16 minus 4 times 1 times 5 all over 2a, 2 times 1, which is equals to 4 plus or minus 2j divided by 2, which is equal to 2 plus or minus 1j, plus or minus 1j, which resembles alpha plus or minus beta j. So we put an arrow to pick our beta, which is 1. We put our arrow to pick alpha, which is 2. Therefore, our yc will be equal to e power 2x into a cos x plus b sin x. That is our complementary function, which when written in the full, it is a e power 2x cos 2x plus BE power 2x sine x. This is cos x. Now we let our yp. Now the normal letting when you have a polynomial 2x, the highest degree there is a degree of 1. So for that portion we are going to let this to be equal to k1 plus k2x up to the highest power. The way we could let when we have this polynomial only. Now when we have an exponential like this, there is a way we normally let when we have a pure exponential. So because there is addition, we also add here and say now we are going to another arbitrary constant because we have serialized our arbitrary constants up to k2. Now we'll go to k3. Now multiplying the exponential 3x. Now this would be the required letting. And before we know it is valid, we check our complementary function. And our complementary function, we don't have a pure constant standing alone. We don't have a constant multiplying x in this expression. We don't have a constant multiplying exponential 3x. Whatever we have here is exponential 2x, but it is being multiplied by some other trigonometric terms, which is quite different from this. So this one is different from the first shown on our complementary function. Hence now it is valid and we can do operation with it. So the first derivative will be equal to k2 plus 3k3 exponential 3x. Second derivative will be equal to 9k3 exponential 3x. 9k3 exponential 3x. But we know something now. D squared minus 4d plus 5. When it multiplies yp, this is the one to generate the 2x plus 5 exponential 3x. This implies what? We pick second derivative that we have here for second derivative multiply d squared multiplying yp means second derivative which is here, that is 9k3 exponential 3x plus, it is not plus, it will be a minus 4 times the value of first derivative, minus 4k2 minus 12k3 exponential 3x. Then we add 5 times the value of yp, so plus 5k1 plus 5k2x plus 5k3 exponential 3x. And this is what should be equated to 2x plus 5 exponential 3x. This implies what? This implies we want to collect those terms that multiplies x power 0, we put them together, x power 1, we put them together, and those terms that are multiplying exponential 3x. So we have here, for x power 0, we have 5k1 minus 4k2. And this is the ones which are multiplying x power 0. The one multiplying x power 1, we only have 5k2. This one is multiplying x power 1. The ones multiplying exponential 3x, we have 9k3 minus 12k3 plus 5k3. This is multiplying exponential 3x, which we should equate to 2x plus 5 exponential 3x. So comparing coefficients. Comparing coefficients, we start with x power 0. We have, not x power 0, we'll start with the highest power of the polynomial. We start with x power 1, which is 5k2 from left-hand side. From right-hand side, it is equals to 2. This implies our k2 is equals to 2 all over 5. That's our k2. X power 0. We have 5k1 minus 4k2 is equals to 2. It's equals to, we don't have a constant. X power 0 is not on this side, so this one is equal to 0. So this implies 5k1 is equals to 4k2. So k1 is equals to 4 all over 5, k2 which is equals to 2 all over 5, which gives us 8 all over 25. 8 all over 25. We go for exponential 3x. The coefficient of that on the left-hand side. On the left-hand side, we can see it is 2k3 only. 2k3. 9 plus 5 is 14. 14 minus 12, we get 2. 2k3 is what should be equated to coefficient of the same this side, which is 5. So our k3 is equals to 5 all over 2. Therefore, our xp, not our xp, our yp, our yp will be equal to k1, 8 over 25, plus k2, 2 over 5, x, plus k3, 5 all over 2, exponential 3x. Therefore, this implies the general solution, y, will be equal to what? The general solution, it is yc, we add to yp. So our general solution will be exponential 2x into a cos x plus b sin x plus 5 over 2 exponential 3x plus 2 all over 5 x plus 8 all over 25. And since there were no conditions given, that is the general solution that was required for that differential equation. Stop.